Okay, so today I'm examining the use of a filter capacitor on a dimmer. So sometimes these dimmers can get quite noisy. So what I'm trying to do is find a way to quiet them down. And sometimes they're blinking bulbs and things like that from not having too much of a load on them. So this Lutron MLC supposedly has a minimum load capacitor, so minimum load might have some sort of resistor on there, right? So and capacitor, because you know a good capacitor for a filtering circuit would be you know, a capacitor, but a better one would be a resistor and capacitor together, also known as an RC filter. So this is some sort of RC filter. I'm going to take a look at the how that performs as soon as we get this all ready to install. So we install this from neutral to the dimmed hot. So I'm going to try to figure out how to do that. And we'll take a look at it. First of all, we're just going to take a look at the noise that we got here. So the input wave that you see scrolling across there is a sinusoidal wave, 120 volts going into the dimmer. The oscilloscope is darn near turned up all the way as far as volts per square. This is an older oscilloscope. So this is the input that the oscilloscope probe is latched onto, and we're going to try to latch it onto the output, and we're going to take a look at what that waveform looks like. Okay, so it kind of looks like a half wave of noise. A little bit of bouncing around there, not so stable, not getting quite a good trigger on the oscilloscope. That's because the dimmer's off. So also I want you to notice that there is not a whole lot of buzzing sound going on. So listen as I turn it on, how my audio system is. Here's the dimmer noise go right through the electrical system. You ready? You hear that buzz? It's audible, you can hear it. Okay, so there's your waveform. I only see a half a wave. It is locked right now. Let me see if I can just turn it a little bit and get it to start scrolling. Alright, so I see it's, there it goes. Oh, I see the whole thing. Every other wave is just a half wave. That's crazy. Look at that. Alright, so let's take a look at what dimming it down means. So that's almost all the way dim. So that looks like a forward phase. Yeah, it looks to me like it's cutting off the forward phase of the waveform. That's the bottom, that's the forward phase, right? So when I cut it back, when I cut it down, you see how it was going down that way? Now I'm almost at the peak of the waveform. Now I'm beyond the peak of the waveform on my backside, and I'm cutting off that too, but it's starting to get unstable. So I'm going to bring it up a little bit, bring it up a little bit. You see how it crept up and filled up the whole top of the wave? I'm just going to back it off a little bit so you can see it just at the peak, right? That's at the peak of the hill crest, so that's filling up just that half, that quarter there, right? And then we're going to go around the peak, and I'm going to fill it all the way up. You see how it's chasing zero over there, but not quite getting it all? So there's like a little bit of a stutter in the dimmer. That's to be expected with most dimmers. So this one, you can see it's forward phase. It's cutting off the forward half of the waveform, but it's still not performing so well. It's making a lot of noise. So we're going to try that, installing that, and we'll be right back to you and film again here. There's capacitor discharging, so that could be quite a bit of surprise. I'm going to connect this back up to the same spot if we can. The dimmed hot. It's on there. Okay, so we've got this capacitor on there with a minimum load resistor. And sitting at idle with it off, it does seem to be a little bit less noise, or the noise got widened out a little bit. It looks like the noise is a little bit fattened up. I'm trying to get the wire away from the screen so you can see it. So it's off, right? And let's turn it on and see if we hear the noise. I still hear the same amount of audible noise. Looking at the waveform, I don't see too much of a difference here. Let's see if I can slow it down a little bit by speeding up the trigger. Okay. Newer oscilloscope would lock into that waveform and just lock it right there for you, but this isn't a newer one. So that's dimmed all the way down. Right there, just a little sawtooth of leakage. Coming up over the backside, getting all kinds of blinking now. Yeah, that capacitor and resistor is not doing so good. I don't know if it's exaggerated the problem and made it worse. But at full brightness, I'm still getting blinking. And as I dim it down, I don't see any improvement in performance. A little disappointed in that. I thought I would have less noise and a better dim performance. But let's take a look at the dimming angle, how fast does it ramp up when it dims? Is it linear, or what kind of angle can we expect there? All right, so it's all the way at the bottom of its curve, right? So I keep on pressing down, so it must have some sort of minimum set point. I'm gonna press once, press twice, 3. I just got that to light. 4. At 4 it starts to blink. 5, that cleared up. 6, 7, 8, 9, 10, 11, 10 starts to blink. 11 clears up. So maybe a more linear dim, but no other improvements really, and it's quite possible it's exaggerated the blinking problem, but can't tell, because that problem does come and go, so it'd be hard to to pin it on the attribute of the minimum load capacitor. Trying to get the dim number down here. You can watch it kind of like go down on the screen here. So what we'll do is we'll go up again. You'll see this part of the wave right here. You'll see that get bigger. So that's like the half sawtooth that comes by every other leakage. That's the waveform. It's crazy how it's every other. And we're going to give it a little bit more, and you should see that start to increase there. Now we're almost up 3/4 up the backside. Now we're at the top of the backside. You can see. Now we're starting to probably come towards the front. I just gave it 2 more. Now we're coming over the front. See how it's coming down? I just gave it 2 more. There you see how it's stretched right in your very eyes. I'll do it 1 more, 2, 1, 2, like that, so you can see it move as I touch the button. It's almost instantaneous. So you can see me 1, 2, 3, or I'll go back down. You'll see it stay the same, then you'll see it go 1, 2, 3 down. You see how that front nose of the waveform got trimmed. So that's the forward phase. It trimmed the forward phase first, and it starts trimming the backside. Just like that. Forward phase dimmers are supposed to be good for low voltage electronics, but in this case, nothing seems to be working for these crappy LED MR16 light bulbs. They're blinking, it's crazy. It's not the greatest light. That's why people still use halogens.